In this experiment, we are going to talk about the Maxwell's reciprocal theorem. Recall that in theory of structures, we discussed the force method of analysis or the compatibility method of analysis for statically indeterminate structures. We used compatibility and force displacement relations to find flexibility coefficients. Maxwell's theorem relates the flexibility coefficients at any two points in an elastic structure. And we are going to verify Maxwell's theorem through this experiment. So what the theorem states is that the displacement of any point B in a structure caused by a load applied at another point A is equal to the displacement at point A caused by a unit load applied at point B. So we are going to use two different setups to investigate this. In the first setup, we first apply the load at this point and measure the displacement at this point. And we do that for a few different loads. Then we switch the point of application of load to here and measure the displacement here. And again, we will repeat that for a number of different loads. Then you would compare the displacements you measured at each of these points for the same loading at the other point. That's the first setup. Here is another setup where you would start by applying the loads at this point and measure the displacements at these 2 points. Then you would move the load to a different point and measure the displacements at the other 2 points and repeat that for the third point. And again, the purpose is to compare the displacements for the same loading at different points.
This is experiment 2, reciprocal experiment. This is the experiment setup. We have vertical member and horizontal member, 2 load trays, 3 500 grams weight, and 2 displacement transducers. Use a metal ruler to measure the dimensions. Move the weight-bearing apparatus to point B and the displacement transducer to point C. Keep the transducer vertical. Next, hang the weight tray onto the weight apparatus. Set the displacement transducer to 0. Add a 500 gram weight onto the weight tray and note the readings on the displacement transducer. Add another 500 gram weight onto the weight tray and note the readings on the displacement transducer. Add a 500 gram weight onto the weight tray and note the readings on the displacement transducer. Repeat the process till the total weight is 1,500 grams. When finished with the experiment, unload the weight-bearing apparatus and weight tray. Also, move the displacement transducer away. The following 4 points are A, B, C, and D. If the weight-bearing apparatus is attached to point B, displacement transducers should be placed under point C and point D. After hanging the weight tray on the weight-bearing apparatus at point B, set the displacement transducers to 0 Repeat the same process as before. Add a 500-gram weight onto the weight tray. Keep adding till the total weight is 1,500 grams. Note the readings on the displacement transducer after adding each weight. When finished, unload the weights. Attach the weight-bearing apparatus to point C and the displacement transducers to point B and D. Repeat the previous process of adding weights and noting the readings on the displacement transducer. When finished, unload the weights. Attach the weight-bearing apparatus to point D and the displacement transducers to point B and C. Repeat the previous process of adding weights and noting the readings on the displacement transducer. When finished with the experiment, unload the weight-bearing apparatus and the weight tray. Also, move the displacement transducer away.